Hi, my name is Long Duan. I'm from eCyberforce. Today I'm going to show you how to configure the Patent Pending MacroProbe for online service monitoring, as well as going over a few examples of online monitoring, especially for the network administrator, as well as other network monitors who want visibility into their network. So let's look at the basic architecture of the MacroProbe. The MacroProbe is hosted on either a hardware or like an appliance or a virtual host in a cloud. It has 4 network interfaces for monitoring: Ether 0, Ether 1, Ether 2, and Ether 3. It can be supported on Windows and Linux, and it has a web client, a web server, and a web client connected to it so that you can do administration, configuration, and monitoring using your web client. So that is because it's simple. It is ideal for small and mid-sized enterprises to deploy readily in their network to start online service monitoring quickly within an hour with minimal configuration. The 4 network interface can be tapped into the access layer or the distribution layer or the core layer of their network. So let's log into the MacroProbe and let's look at the policy configuration. So when you log into the MacroProbe, the main menus, the home page is the cyberspace management, where you can do all sorts of configuration and monitoring. One of them is the first thing you need to do is log in as a system administrator. Is user management, is to create user. Like create user, update user, and all that. Second thing, once you create the user and all that, the network manager, network administrator should log in and create policy management, create a policy, what they want to monitor in their network. So basically, there are 4 categories in policy management in monitoring. The first category is network monitoring, right here, and unknown traffic monitoring, and recording. So unknown traffic and network monitoring will monitor for link, application, server, and flows. The second category is online service monitoring. These are the DNS monitoring, HTTP monitoring, SMTP monitoring, IMAP4 monitoring, POP3 monitoring, FTP data monitoring, as well as TCP application monitoring. These are all the applications flowing on TCP transport that are having well-known IANA ports. The third category is end-to-end service delivery monitoring. These are the internet service monitoring, email service monitoring, file service monitoring, custom internet service monitoring, and data center service monitoring. So those are the three categories: network monitoring, online service monitoring, and end-to-end service delivery monitoring. And the MacroPro performs three basic functions on the three categories. The first basic function is data collection. It logs 1 minute resolution data every minute on all the network interface that the MacroPro runs on. So at any time you can have up to 4 instances of the MacroPro running on each interface. And the second category function is the analytics. Right here, monitoring, then analytics. Monitoring for data collection and analytics for automate analysis of using the log data to go to the analytics to every 5 minute and hourly schedule to automate the analysis of the data. So the monitoring in the data collection is for manual analysis. The analytics is for the automate analysis. I think that when you are familiar with your enterprise, you can automate all that manual monitoring so that you can detect alarm on the dashboard and the alarm viewer, and that makes your life a lot easier. And the third function is this reporting a packet for troubleshooting at packet level. This is the continuous recording of packets on the network for troubleshooting when the manual analysis and automate analysis fail to find the root cause of the problem. So you have to resort to troubleshooting and find out the root cause of a problem at the packet level. But we don't want to go to that level of details. If you can solve the problem at the analytic level or the manual analysis level. So today we will go over the example of policy management for DNS monitoring, and HTTP monitoring, and TCP application monitoring. These are all the applications on the well-known IANA ports that are transport on a TCP transport. And then we're also going to go over the monitoring of the internet service in the end-to-end service delivery. And we're also going to go over the custom internet service in the end-to-end service delivery monitoring. So the MacroPro is already set up to monitor and do analytics of DNS, HTTP, internet service, and custom internet service. We will not go over the analytics side today. We will go over only the manual analysis of the collect data as an example of the manual workflow. So let's go to the home space. and look at the service monitoring. When we launch a DNS monitoring, let's say launch it for last 24 hours on this monitor interface, 10.20.100.71 DNS monitoring. So we can sort by the server. Right here. So we're going to launch the DNS response time over time on the server. Pick 192.168.39.150 for the last 24 hours. So now on this chart, you can see the correlation between the DNS server response time and its load in terms of transaction. So this is the 1 minute data, log every minute for the last 24 hours. So you can look into this and look at this data at this timestamp. Transaction equal to 14 and the response time equal to 6 at 9 o'clock this morning. So that's for performance monitoring on the DNS server. Now, if we want to monitor for error, protocol error on the DNS server, we probably want to sort by the worst error server. So this one right here, 69.36.145.33 has the most server failure error. So we're gonna launch it for the last 24 hours, chart it out. And as you can see, there's a correlation between the DNS server failure on this server and the transaction load on this DNS server. Every minute of it. Well, not every minute of it, but over time, in the last 24 hours. We can look at the server reviews, sorted by the worst server reviews. And this one right here, we have the worst server reviews, which is 1. So we can launch DNS server reviews over time. And here we have a correlation between the server reviews, protocol error, and the transaction load. Basically this morning at 10:33. There aren't too many of these server reviews error on a DNS server. So that is a brief overview of the DNS monitoring. Next we come to the HTTP monitoring. We want to do it for the last 24 hours. We want to sort this. Yep. We're looking for the server that has a decent amount of data. This one right here have good data. So we're gonna launch HTTP server response time over time. So now we're gonna see the chart displaying the correlation between the DNS server or the HTTP server response time versus its load in terms of transaction every minute of it for the last 24 hours. So in terms of error, we're gonna sort by the worst error there is. Nope. Sort by the worst error. So this one have one 5xx error. So let's launch on this 5xx status 5xx HTTP status code over time. So we do see the correlation between the HTTP status 5xx error on the server 208.112.1.171 versus its transaction load. That's a brief overview of the HTTP monitoring. Next we come to the TCP App Monitoring. So we go into network monitor and TCP last 24 hours, TCP monitorings. And in terms of looking at all the applications that are detected on TCP ports that have response time, we can see that this one right here, let's see the worst one, the worst response time, LDAP. So let's see what the application response time over time. So here's a correlation between the LDAP application versus its client server flow load for that LDAP server over the last 24 hours. This is the response time, and this is the flows. So next, we want to see the TCP reset error. We want to see the worst TCP reset. So SMTP has the worst TCP reset. So we want to launch application or TCP application on reset over time. And now we see the correlation between the TCP reset on SMTP versus its load as the number of flows on that application. Now we want to look at CWR count, the word CWR count, congestion window reset. So FTP control seems to have the worst one. So we look at this and we see the correlation between the TCP CWR on FTP control versus the flows on FTP control. So now we're gonna pick an application to drill down to the, let's pick IMAP 4, drill down to the TCP application server. So we have 10.21.20 and 192.168.1.214 are the server under IMAP4 application using the IMAP4 application. So we can look at the response time. So here we have the IMAP4 server response time over time versus the number of clients connecting to it. Response time and the client. So in terms of the server reset, we see the server reset for the IMAP4 server correlate over time with its load, and IMAP4 server CWR is 0. CWR is 0 for this IMAP4 server. So that is for the server. Now we go down, drill down further down to a flow. So we have the server 10.21.20 talking to the client 10.21.3, and we can look at the reset over time on this flow, and we can have the correlation between the session, number of sessions versus the TCP reset on the flow over the last 24 hours. We can have the flow response time over time. We have the correlation between the response time of the flow versus the session that the flow is having at every minute in the last 24 hours. And we can have the flow CWR over time. It's 0. CWR is 0 for this flow. 0. So that is the brief overview of the TCP App Monitoring. Now we're going to go over the service end-to-end service delivery for internet service monitoring. So we go in here, service monitoring, and we pick internet, where in the multi-tier and multi-location service monitoring for internet, the Micropro correlate among its 4 physical monitor interface on DNS and HTTP. Usually on internet service, first you type in google.com and the client send a DNS request to the DNS server to resolve the google.com domain to the local IP address serving the google.com in that region. And then the client send an HTTP request to the local Google server. So that's how this architecture is made. So if your DNS server is down, pretty much your internet server is down. Or if your HTTP service is down too, the local serving google.com is down, your internet service is also down too. So this is the interdependency between DNS application and HTTP application that the Micropro correlate among its 4 physical interface. So let's do this. There are 2 ways to analyzing this. One for performance, the other one is for functional protocol error. So let's look at performance first. For the last 24 hours on this particular performance DNS server, we want to start with an interface where we know that the DNS server is detected, and we want to see what is the worst performing DNS server. So we're going to sort it by server, and this one right here has good data. Remember, DNS server, this location is where the DNS server is detected. The location is designated by the IP address of the segment that the MacroProbe is tapped into, and it shows the DNS server response time. Now, what we want to do is, well, we can look at DNS server response time over time, and we can see that over this region right here, there's a lot of bad response time in today, early in the morning, until now. So let's drill down to the worst dependent HTTP flow. That are using this DNS server 192.168.39.150. So these are the dependent HTTP flows that use this DNS server 192.168.39.150, and let's see which one. Let's sort it by the server. So we do have a lot of dependent server on this DNS server. A lot of resolution done by this DNS server. Let's sort it by. So let's sort it by the worst response time. So this one right here, worst response time, and we want to look at the DNS server in correlation with the HTTP server response time over time, because we're looking at performance of both the DNS server and the HTTP server that are dependent on each other. So now we see the chart that correlate the DNS server 192.168.30.139.150 versus the HTTP server 204.127.225.14 that use this DNS server. We see the correlation between the HTTP server response time and the DNS server response time. So we're going to drill down further to the DNS and HTTP flow response time over time on that particular server. We have a similar behavior because it's a server that have a single client. So that's for performance monitoring for the internet service. Now we go back to the error. Protocol error. So first, for the last 24 hours, we want to look at the worst error DNS server. So let's sort it by server failure. What have the worst? Which one have the worst server failure? And 69, 36, 145, 33 has the worst DNS server failure. So we're gonna launch it. DNS server failure response time over time. And we see the chart in correlating the DNS server failure and its transaction for the server. We can drill down further to most error-dependent HTTP flow for that particular DNS server. So on this one, we want to see there's no 5xx error, but there's 4xx error, so we're going to sort it by 4xx error for the worst 4xx error. This one right here, this flow right here, HTTP flows. So we're going to chart it. 4xx. So we're going to chart the correlation between the DNS server error and the HTTP server with the 4xx error over time in the last 24 hours. And we're going to do the DNS and HTTP flow over 4xx over time. Similar behavior because this single client. That's pretty much done for the monitoring internet service from end to end, service delivery. Now we're going to look at the monitoring custom internet service, end to end service delivery. These are the DNS that resolve through TCP applications that are on a well-known IANA ports that transport on TCP. So let's look at this. Go to service monitoring, and we go to generic and custom DNS to TCP App Internet Service Monitoring for the last 24 hours. So we're gonna look at performance first. So the DNS server look at the response time. Well, look at the server. This one right here, I know have data, good data. So we're gonna analyze this DNS server 192.168.1.1 in resolving all the well-known TCP app ports like Oracle, Postgres, LDAP, HTTPS. So we're going to look at DNS server response over time. So now we see the correlation between the DNS server 192.168.1.1 versus its transaction load. We're going to drill down further into the worst dependent TCP app. What are the TCP apps that are depending on that DNS server? So from this one right here, we can see that there's HTTPS and HTTP and IMAP4 and SMTP and POP3, and the location of it is a different location, 10.20.100.71, 10.20.100.72, and we'll see that the TCP app response time as well as the TCP DNS server IP and the DNS server location and the DNS server response time all in one stick together. So what we're going to do is let's look at IMAP4. Well, let's look at worst response time. So this server, this application HTTPS have the worst response time using this DNS server. So let's chart it, server app response time over time. This is the correlation between a DNS server 192.168.1.1 versus the HTTPS application. So we're going to drill down further to TCP app server that use that DNS server. So what we're going to do is we see the IP address of the HTTPS server and its location and the dependent server HTTPS server response time and the DNS server and its DNS server location and the DNS server response time for that particular HTTPS server. Let's sort by the worst response time for HTTPS server. So this one is the worst one, so we want to look at that. DNS HTTP server response time over time. So now we see the worst HTTPS server response time that use this DNS server 192.168.1.1. intercorrelating between the DNS server response time and the server response HTTPS server response time. So now we're going to drill down further to the HTTPS flow on that particular HTTPS server, and we're going to chart out the DNS server and the HTTPS flow response time over time. So now we have a correlation between the HTTPS flow and the DNS that use the DNS server 192.168.1.1 in response time. So that is done for the custom internet service monitoring end-to-end. Now we're going to look at the custom internet service error end-to-end. So we'll start looking at the protocol error in the custom internet service. Last 24 hours. Last 24 hours. Most error DNS server. We're going to sort it by the server failure, DNS server failure. So for this one, this is 69, 36, 143, 33 have the worst DNS server failure in the last 24 hours. So we're going to chart it out over time in the last 24 hours and see how it's behaved. So we have a correlation between the server failure and the transaction load on that particular DNS server. We now drill down into the TCP app that depends on that DNS server for resolution. So there's HTTPS application and HTTP application at different location, detect at different location, and you can see the TCP App reset and TCP App CWR error as in comparison with the DNS server location and DNS server failure and DNS server refuse, all superimposed in one line. So now what we want to do is sort it by the worst TCP reset. So this HTTPS have the worst TCP reset. So we chart it over time. So we now have the DNS server failure on the DNS server versus the HTTPS application TCP reset corresponding to it in a timeline in the last 24 hours. We don't have any CWR error, so we're not going to launch it. So what we're going to do is drill down further from that HTTPS application that have the worst TCP app reset into the TCP app server. So these are the TCP app server under the HTTPS application. So we're going to sort it by the worst HTTPS server TCP reset. So this server have the worst TCP reset. So we're going to chart it. So now we have the DNS server failure and the HTTPS server reset in correlation for the last 24 hours. So now we're going to drill down further to HTTP flow, dependent HTTP flow. So this is the HTTP client that used this HTTPS server in this location, and I have the was TCP reset, HTTPS reset, and using the DNS server at this DNS location, and having DNS server failure and DNS server refuse. So we chart this over time. And here we have the DNS server failure and TCP reset correlation for the last 24 hours on the flow. So that concludes the online service monitoring